So let's have a look at angles. Here's a grid measuring degrees from 0 degrees, and we go around in the anti-clockwise positive direction. One full turn is 360 degrees. So if 360 is one full turn, half a turn would be 180, halfway round. Quarter turn is 90. So you go around 90, 180, then 270, then 360. And that's the anti-clockwise positive direction. You can subdivide degrees into minutes. 60 minutes is 1 degree. And you can subdivide minutes, believe it or not, into 60 seconds. And I've written the units down here. So 60 minutes is 1 degree, and 60 seconds is 1 minute. Okay, just a note about angles. If you say an angle between 0 and 90, it's called acute. A 90-degree angle is a right angle. Between 90 and 180, an angle is called obtuse. And between 180 and 360 is called a reflex angle. So it's just the notation and terminology. Now we want to convert these. We're just going to use a calculator to do this rather than by hand because it's easier. And see how we do it. Let's have a look then. Let's do the first one. So we've got 31 degrees 51 minutes, and we want to convert it to decimal. 31 degrees 51 minutes. There we are, 31 degrees 51 minutes. If we go to decimal, we get 31.85. So it's 31.85 degrees. And then next one, 52 degrees. 52 degrees, 25 minutes, 6 seconds equals, there we go. And then convert that to degrees. We get 52.418 to 3D. And that's the 3 decimal places. And that was degrees. 27.65 then, let's put that in. 27.65 and go to equals decimal, and then we'll go to degrees. 27 degrees 39 minutes. 27 degrees 39 minutes, and 73.18 degrees then. 73.18 degrees. Go to minutes. 73, 10, 48. 73, 10 minutes, 48 seconds. So we'll use the calculator. So if we want to add up these, for example, just tap them in. 19 degrees, 47 minutes, 20 seconds, plus 35 degrees, 46 minutes, and 32 seconds equals, that was minus, wasn't it? And it looks like 55. I don't know whether I've written it correctly. 32, 35 plus, I'll put a minus here. It helps to write the question in correctly, of course. And also I need to do 74. Oh, I've got that all wrong. So let's just delete that. Don't know where that came from. Probably read the one above. 74. Oh, I am doing the one above. Oh, I probably had it right then, didn't I? Let's do it again. 19 degrees. Only take a moment. 47 minutes and 20 seconds. Plus 35 degrees 28. 28 and 16. 28 minutes and 16 seconds. There we go. Let's have a look where I've gone wrong. 35, 28, 16 seconds. There we go. 55, 15, 36. 55, 15, 36. Degrees, 15 minutes, 36 seconds. Next one. 74. Hopefully I'll get this one right. 34 minutes and 48 seconds minus 35 degrees 46 minutes and 32 seconds equals 38, 48, 16. 38, 48 minutes, 16 seconds. 38, 48, 16. Yep, that's fine. Good. So converting from one unit to another then. The easiest way to remember it, this is radians. So instead of going around 360 degrees, you can go around from 0 to 2 pi radians, and that's also a measure of unit of angle. So if you go around half of 2 pi, it would just be around pi, wouldn't it? 180. If you go around quarter, that's 90, that's pi over 2. So the way you go from radians to degrees and vice versa is just to remember the formula fractions of a circle. So 90 degrees, fraction of 90 degrees as a fraction is 90 parts of 360 of the circle in radians then, and that's what you tap into your calculator. Here 45 as a fraction is 45 3/60ths. Fraction of is times, a circle is 2 pi. And then 30 over 360, fraction, 30 3/60ths of a circle 2 pi. Here you've got 60, so it's 60 parts of 360. That's the fraction, isn't it? Of the circle, 2 pi. Then you've got 120 over 360 here. Fraction of a circle. And then 300 over 360. Fraction of a circle. 43. I'll have to tap that one in a calculator. Of a circle. And then you've got 239.48 fraction over 360 of a circle 2 pi. So that's the fraction of a circle. I'll do some of them, if not most of them. So here that's a quarter, so that'd be pi over 2. This is 1/8 when you work it out, so it's pi over 4. This is 1/12, so it's pi over 6. 1/6, so this is pi over 3, isn't it? This is a third, so this is 2 pi over 3. And 300 over 360 is 10/12, 5/6, so it's 5 pi over 3. Now 43, let's use your calculator to get the decimal here. 43 divided by 360 times 2 pi times a 2 pi. There we are. 43 divided by 360 then. There we go. Times 2 pi. Get the decimal, 0.75 to 2 dp. And 239.48, let's just do it quickly. I'll just go back here, just change the 43, it's the same formula. 239.48. .18 to 2 dp. Okay, good. Now to go from radians to degrees, again it's the fraction, so that's 3 pi over 4 over the full circle 2 pi, fraction of the circle in degrees. So this would be, the pi's would cancel, we get 3/8. So that, when you tap that in the calculator, 3/8 of 360. 3 divided by 8 times 360. 135 degrees. 5/12 fraction, so it's that much of 2 pi as the whole circle of the circle in degrees, fraction of a circle. 5 over 12, so it's 5 over 24, isn't it, as a fraction, times 360. 5 over 24 times by the 360, 75 degrees. 7/15 as a degree, 7 pi over 15, fraction of the circle, that's the fraction of the circle in degrees. Because it's 7 pi over 15 parts of 2 pi, isn't it? So that'd be 7 pi over 30. So 7 divided by 30 times the 360, because the pi's cancel. 84. 1.49, so it's 1.49 fraction of the circle in degrees. So 0.49 divided by bracket 2 times pi, because they're all underneath, close bracket, times by 360 degrees. 85.37. It's 2dp. 4.5, let's go back and just change the 1.49 then to 4.5. 257.83. 257.83, I think it was. That's 4.5 fraction of the circle in degrees. Okay, so that's how we convert from one unit to the other then, degrees to radians and radians to degrees. So here's just a way to measure angles. Remember, we start from 0 and this is the positive direction. So if we go back about this much, a bit more than that pictorially, get minus 60, minus 90 because it's negative direction, minus 150, that's minus 180 there, then it's minus 225. So this would be minus pi over 3, wouldn't it? And this would be minus pi over 2. This would be minus pi over here. That one would be something. And this would be something else because it's a 45. Not going to worry about the awkward fractions, we could calculate those as well. But just to get the notion of that's the positive way and that's the negative way. So if you had, say, 450 degrees, for example, you'd have to go around 360. You'd have to keep going around to another 90, wouldn't you, to 450, and there's the angle around to here. So it's one full turn and a bit more, another 90. Okay, so that leads us on now we know about angle, to looking at triangles, right angled triangles, and we have this formula SOHCAHTOA. The sine equals the opposite over the hypotenuse, so cosine is the adjacent over the hypotenuse, CA, and tan is the opposite over the adjacent, TOA. So as far as the angle is concerned, this is the opposite side. This is the adjacent side next to it, and this is the longest side, the hypotenuse. So depending on your angle, we'll determine which one is the opposite and which one is the adjacent. So it's in that context that we read off SOHCAHTOA. Sine 28, let's just have a quick look at that. Oh, let's get the calculator. Sine 28. Now we need to be in degrees mode here, don't we? So shift mode, we want 3. Now we're in degrees mode. So now we can do sine 28. So sine 28, 0.47 to 2dp. Cosine 52, 0.62 to 2dp. And tan 71, here it is here. In degrees mode, which we're in, 2.90. So there's sine, cos and tan then, and how we use them on the calculator. Okay, now if we had, I think that'll do for now. And we'll do the next part, little introduction, before we do question 1 of the exercises.